All right, this is an introduction to a whole bunch of reactions I'm going to talk about in more detail in individual videos. So, Chapter 20, conversion of carboxylic acids to carboxylic acid derivatives. All right, so the carboxylic acid, we can turn it into any of the other derivatives that I introduced in that first video. There's basically four ways of doing this, okay? So, the first way, and really kind of the foolproof way, is to convert the carboxylic acid into the acid chloride. All right, remember that video I did with the stability to hydrolysis? That's really stability to nucleophilic attack. And the acid chloride's up on top of it. So you sort of climb the mountain all the way up to the acid chloride, and then you can fall down to whatever little village you want. So SOCl2 is going to turn the OH into the chloride. There you go. You have you know this reaction, right? You know this from alcohol chemistry, where we can turn an alcohol OH into a chloride with SOCl2. You can do this with PBr3, so you can make an acid bromide or an acid iodide, or even an acid tazolate. People don't normally do that. Acid chlorides are already reactive enough that making those more reactive substances is unnecessary. And then, if you treat the acid, so the acid chloride is a derivative on its own. If you treat the derivative with a nucleophile, and I guess I should say, this is usually going to be a nucleophile anion or a nucleophile H. Typically, the protonated, the neutral nitrogen is a good enough nucleophile to attack the acid chloride. For these two, for the thioester and the ester, you typically want to use either RS minus or RO minus. And again, I'll talk about that in a separate video in detail. And so this will, basically, if you make the acid chloride, you can get to any of the other derivatives. And I should say here, the acid anhydrides will also do this reaction. Acid anhydrides essentially do every reaction the acid chlorides are going to do. And so I'm not going to spend a lot of time talking about the anhydrides. But it's worth noting that in biochemistry, you'll also see activated carboxylates with a phosphate out here. All right, so you'll see this in biochem, Chem 370. And this is going to act like, right now the phosphate is a good leaving group, and this is really going to act like an acid chloride. All right, the second way you can make an acid, or convert to an acid derivative, is just by an SN2 reaction with a nitrile, or with cyanide, right? If we do an SN2 here, so again, this can be any SN2 leaving group, chloride, bromide, iodide, sulfonate ester, whatever. You get a nitrile, you've added a carbon, so there's your derivative. You've made a nitrile. And then look at this, if you hydrolyze it, you can get to a carboxylic acid that's one carbon longer than the initial halide you started with. The third way of doing, the third way to go from an acid to a derivative is to take your carboxylic acid, some nucleophile, either the thiol or alcohol or amine, and this reagent called DCC, dicyclohexyl carbodiamide. I think that's actually found in chapter 22. I like to talk about it here. And this reaction is most common to make amides. So the carbodiamide chemistry comes in the amine chapter because we can turn amines into amides. But you can do it with thioesters and esters as well. I've done that myself. And then the fourth way, and I'm going to hit this one pretty hard with the mechanism. If you take a carboxylic acid with an acid catalyst, this needs to be dry now. There needs to be no water present. So it's the reverse of a hydrolysis. So an acid catalyst and an alcohol, then you can esterify the acid. You can only make an ester this way. All right, so like I said, there's going to be videos, if not for all of these, for some of them down the way.